time. Welcome to my channel. Are you ready? Let's So once we have we know that the inverse exists, the question normally asks us to do next is to find the inverse function. So to find the inverse function, there is two methods. One is the method of mapping that you have already studied during your advanced days. Personally, this is like my favorite. But then there is few word of caution that I'd like to ask you to do, whereby please first of all draw out this mapping. Okay, so whereby you got x, you got y. So f will bring x to y will be brought to x by f inverse. So make sure you write down this statement very clearly. Okay, this statement very clearly, and write this statement, we know that. So that nobody can question that you are doing this, okay, based on assumption. Okay, that is one. So once you got that, okay, I can go and do, okay, the inverse function using these two information. So how do we do that? So here, domain already defined, meaning to say I only take the part of x greater than or equal to 0. So the first information is when I see fx, I'm going to go and replace with y lah. Okay, so I'm going to do that. So once I do that, I'm going to go and get expression for x sama dengan kenapa. Why do I want that? Okay, because you can see here, the second information is x equal to mah. So I go and get x equal to. Of course, here you get plus minus, but then based on the domain, this guy is not here for decoration. You choose the positive. So I get that. Okay, use the second information. Remember this one, this y you can simply replace, meaning to say I put 1, here's a 1, put 2, here's a put 2, here I put 3, here's a put 3, here I put x, here's a put x, hence I get the inverse function. So this is using the mapping method, nice and easy. However, if you are the person who like to use this identity, okay, so this is the second method. So you can use this identity also, no problem. So f, okay, composite f inverse, you get x. So this is an identity. Okay, so you can see here, what I do is, okay, since this is a function, I go and work out my own f of f inverse. So meaning to say the place of x has been replaced by f inverse of x. So here you see x, x. So I put f inverse here. Here's why I put f inverse. Hence, what will happen is, there you go. So you got fx ma. So I want to go and work out what is this guy. So the place of x has been replaced by this. Hope we are clear up until that. F of f inverse, you get this. At the same time, I know property f of f inverse is x. So these two guys are going to be to get same. And then it's just a method of rearranging the 3. I go this side, become minus. Then I don't want the square, I take square root. Okay, so this is the second method of finding the identity. So my advice is you need to know both methods. So up to you which method you want to use. Okay, so now we got our inverse. Normally they will ask you to sketch f and inverse on the same axis. So here is where they are. So please make sure, okay, you can come up with your symmetry, you show your symmetry. What do I mean by that? Okay, so for example here, okay, this one is your quadratic, right? Actually, this number here should be 3. If I'm not mistaken, the function that I'm using is 3, if I'm not mistaken. So if it is x squared, okay, plus 3, then this guy should be 3 here, Apologies for the error. So your quadratic, you're only taking this part of the graph. So what the examiner would like to see is you are using the symmetry property whereby you are reflecting one of the graph about the line y equals x. So meaning to say if you have already drawn f, then you're obtaining f inverse by reflecting. So you can make use of the point here. For example, dekat sini, I put 2 mah. So if 2, okay, this is coordinate 0, 2 mah. 0, 2 when you reflect about y equal to x will become 2, 0. Then this guy going like that. Then this guy will go like that, whereby this distance is the same. This guy moving away, make sure this guy moving away. Label everything clearly. And then finally, make sure you can tell what is your domain and range. Okay, you can see the relation. Here, domain of f, of course, is the value of x where the graph exists. It's going to be from 0 to infinity. That is going to equal to the range of f inverse. Range means the value of y where the graph exists. So here the value of y exists from 0 up until infinity. So domain of f is going to equal to the range of f inverse. Similarly, range of f going to equal to domain of f inverse. Okay, hope you don't have any problem with that. And I would like to wrap up by talking about some tips. Watch out for the words like inverse of each other. So this one, in order to do that, you need to go and find, okay, composite of each other. Okay, meaning to say, if they ask you to do FG, GF, so that is. Okay, hi everyone, so welcome. So this is what I was trying to actually tell you. Okay, basically you need to watch out for the words like inverse of one another. Okay, so this is something that you can expect. So when you have this kind of question, this is a PSPM question by the way. So what you can expect is you should be trying to do composite of P and Q, and then Q and P. Okay, and try to prove that they are inverse of each other. So when you got that, normally the expected answer is when you do P and Q is X, Q and P is also X. Okay, so that is what you should be looking forward. Okay, so without wasting time, let us go and do, okay, my composite function. So first we start with P composite with Q. So you know you will disturb Q first. So you go and put in what is Q. What is that? So I want to evaluate this. Of course, I need the function of P. So you can see the place of X has been replaced by this. So sama nampak X, you go and replace with this guy. So that will give you this. So now it's a matter of us simplifying inside. Okay, the 3 you multiply in and going to get this. 6 and 6 going to cancel out and you end up with this. So law of log, whereby the power can go in front. And we should understand that ln of E is just equal to 1, which will give us X. So as expected, okay, when we do the composite, you're getting X. Let us go and do the other one, which is Q composite with P. So, you know, we will start with P. So our P is this guy. So replace. I want to evaluate this. So of course, you can see the place of X now will be replaced by this chunk here, ln, which will give you this. Okay, because the X has been replaced by this. So get that. So now I can go and simplify. This is property E ln X. You should get X. So E ln 3x plus 6 would just give you 3x plus 6 at the top over 3. Simplify this guy and that should give you just X. So as you can see, PQ, you get X. QP, you get X. Let us write that down. Okay. And this one we can go and compare with the property. So the property of inverse function is, if I do composite of P with P inverse, that should give me X. Composite of P inverse with P, that would give us X. So by doing comparison, P, X, I can conclude Q is actually P inverse. Or you can actually take this property here. Okay, X equal P, Q is actually P inverse. So you need to conclude Q is actually P inverse. So that would mean P and Q are inverse of each other. Hope that makes sense to you. So of course, we have to go and try a lot of questions on chapter 5. Catch you in the next videos. Let's keep going for PSP. Adios, guys.